Hello, my intelligent A student. We will start the video by solving the questions from our earlier take-home. Were to convert to base 10. Question 1. We had 0.11 base 2. 0.11 base 2. So what's the first thing? Like I said in the previous video, before the decimal you start with indexing from 0. After the decimal, you start indexing from -1, -2 up until the last number. So this becomes 0 times the base you are working with 2 raised to power 0 plus 1 times 2 raised to power -1 plus 1 times 2 raised to power -2. Anything raised to power 2, anything raised to power 0 is what? Is 1. So this becomes 0 times 1. This becomes 1 times minus anything raised to power negative becomes 1 over 2 raised to power 1. 1 times 1 over 2 raised to power 2. So this becomes 0 plus 1 over 2 plus 1 over 4. 0.5 plus 0.25. So this becomes 0.75, which is to convert 0.34 base 8 to base 10. So what's the first thing? You give each digit an index. After the base, -1, -2. Before the base, 0 up until the last. So this becomes 0 times the base 8 raised to power 0 plus 3 times the base raised to power -1 plus 4 times the base raised to power -2. So this becomes 0. So this becomes 3 times 1 over 8. This becomes 4 times 1 over 8 raised to power 2. Remember, when you have a negative index, negative power, it becomes 1 over 10. The question without the negative sign. So this becomes 0 plus 3 over 8 plus, so this becomes 0 plus 3 over 8 plus 4 over 64. So this becomes, taking 64 as the base, as the LCM, 1864 is 2. 2 times 3 is 6 plus 4. That's 10 over 64. You can do it this way, or simply just use your calculator to do 3 divided by 8, which would give you 0.375 plus 4 divided by 64, which would give you 0.0625, and then add the two together to give you 0.4375, and you would see that when we just do 10 divided by 64 to give us 0.15625. So there's a mistake somewhere. 8 divided by 64 is 8. So 8 times 3 is 24. Not, so this should be 28 divided by 64. So that will give us what is correct, 0.4375. You see that this, either method, you still get the same answer. So the third question, 14.232 base 5. So after the decimal, -1, -2, -3. Before the decimal, 0, 1. So this becomes 1 times the base 5 to power what? 1 plus the next digit 4 times the base 5 to power of 0 plus the next digit 2 times the base 5 to power of -1 plus the next digit 3 times the base 5 to power of -2 plus the next digit 2 times the base 5 to the power of minus 3. So this becomes 1 times 5, because 5 raised to the power 1 is 5, plus 4 times 5 raised to the power 0 is what? 1, plus 2 times 5 raised to the power minus 1 is 1 over 5 raised to the power 1, 3 times 1 over 5 raised to the power 2, 2 times 1 over 5 raised to the power 3. So this becomes 5 plus 4 plus 2 over 5 plus 3 over 25 plus 2 over 125. So overall this becomes 9 plus 125 as LCM. 5 in 125 will give us 25 times 2, 50 plus 25 here give us 5. 5 times 3, 15. 225 here 1 times 2, 2. So this will give us 9 plus 67 over 125. So you can write it as 9 over 67 over 125 if you choose to, or you can simply do 9 plus 67 divided by 125 would give us 0.536, and this will be 9.536 base 10. And the final question, we have 5EB.3F base 16. So this, before the decimal, to your moving from your right hand to your left hand side, you start 0, 1, 2. After the decimal, moving from right hand side left to right, minus 1, minus 2. So this becomes 5 times 16 raised to the power 2 plus E times 16 raised to the power 1 plus B times 16 raised to the power 0 plus 3 times 16 raised to the power minus 1 plus F times 16 raised to the power minus 2. So this becomes 5 times 16 raised to the power 2 would give us 256 plus E in hexadecimal will be 14. 14 times 16 raised to the power 1 is 16 plus B in hexadecimal is 11, and 16 raised to the power 0 is 1 plus 3 times 1 over 16 plus F. F is 15 times 1 over 16 raised to the power 2. If you don't understand why F is 15, why B is 11, why E is 14, you need to check the previous video. I've explained in details when I explained the concept of hexadecimal. So this becomes 5 times 256 will give us 1280 plus 14 times 16 will give us 224 plus 11 plus 3 over 16 plus 15 over 256, and this becomes 1280 plus 224 plus 11. That will give us 1515 plus, you can either do the fractional part or just do 3 divided by 16 to give you 0.1875 plus 15 divided by 256, and that will give us 0.0586 approximately. So all of this will become 0.1875 plus 1515 would give us 1515.2461 approximately base 10. Right, so we move to the video for today. So guys, in this video we'll be looking at fraction of numbers from base 10 to another base. This concept is very simple. What do you need to do? The only thing you need to do to convert from a base 10 number to another base is to continuously divide and record the remainder. To convert a number from base 10 to another base, you continuously divide the base 10 number by the base you want to convert to and record the remainder. For example, you want to convert 117 base 10 to a base 8 number. What do? You continuously divide 117 base 10 by 8 and record the remainder. If you want to convert 269 base 10 to a number in base 4, what do? You continuously divide by 4. You continuously divide by 4. So that is the concept, to continuously divide and record the remainder. And why does this make sense? You remember earlier in my previous video, I explained that for a particular base, the number of digits that can be in that base is from 0 to the number that precedes that base. So, of course, when you divide by a particular number, the remainder would only be from 0 to the number just before the number base you are working with. So, that is why this makes sense, right? So, now let's solve some examples under this concept. So, let's take some examples. Convert the following from base 10 to the base indicated. So, example 1, convert 117 base 10 to base 8. Convert 269 base 10 to base 4. 7385 base 10 to base 16. 28 base 10 to base 2. So I'll start with question 4. Question 4 says convert 28 base 10 to a number in base 2. What do? We say we continuously divide the base 10 number by the base we are converting to, right? So to make this easier, we have to draw a table, sort of. We have to draw a table, something like this. Then the number, base 10 number, you write it at the right hand side here. Then pick the base you want to convert it to, which is in this case base 2, at the left hand side. Then you continuously divide. A lot of students make mistake in this division, and to make your life easy, that's why you have calculator. If you know that you would continuously make mistake, of course WAEC also would give you calculator, right? So just do 28 divided by 2 is equal to what? 14 plus what? 0. This plus is, some people use R, showing that remainder 0. You can use remainder 0 as in R0 or plus 0. It's still the same thing, right? It's still the same thing. So you see that this, from our calculator, this gives us perfect number 14. There's no decimal, so we write 0 because there's no decimal, there's no remainder. You remember, the key word here is continuously divide until there's nothing left to divide by. So this 14 we divide it by 2 again. So 2 divided by 14 will give us what? 7. Remainder also what? 0. Now 2 divided by 7 will give us what? 2. Right? 2 divided by 7 will give us 3 rather. Right? Remainder what? 1. Now most students really get confused when they are doing this remainder thing. So let me teach you something that would help you to master it with calculator. So in our case, 7 divided by 2, you see, it gives us what? 7 over 2. If you are using this type of calculator, just press this SD button here. It will give you 3.5. So you know that 3 is the whole number here. So you write the 3. Now for the decimal, which is 0.5, don't confuse yourself about that. What you just do, once you have written the whole number 3, then do 3 times 2. 3 times 2 will give you what? 6. Right? Now, which number were we dividing it initially? 7. So 7 minus 6 is what? 1. So that's how you get your remainder 1. For people that are not very versed with multiplication table and division, this is a way to make it easier for you. So 2 divided by 3, we say 3 divided by 2 will give us what? 1. You write 1. 1 times 2. 1 times 2 is what? 2. So what makes this 2 to complete to 3 is 1, remainder 1. So 2 divided by 1 is to not go obviously, so we record 0, it will remain the 1 like that. So when you get to this point, that is our bus stop, because nothing can go again. You can't continue to divide 0, because 0 divided by 2 keeps us giving them 0, 0, 0. So now when you get to this point, you want to record your remainders. Remember, we say that we will record the remainder. Record, continuously divide and record the remainder. Right? So we have continuously divided this. Now, how do we record the remainder? You start from the last remainder here and go up all the way. So our 28 base 10 will become, starting from the lowest part, we'll keep writing it 1, 1, 1, 0, 0. Base, the base we are working with is 2. So let's start with number 1. 117 base 10 to a number in base 8. So like we said earlier, in converting from base 10 to any other base, the bone of contention is to continuously divide the base 10 number by the base you want to convert it to. So in this case, 117 is our base 10 number. We write it on the right hand side, then write the base we are converting to, in this case base 8, on the left hand side, and we continuously divide. So like I said, using calculator, for most people that have, for most students that have issues with multiplication table, it's safer to use calculator. So how do you use it in a faster way? Just do 117 divided by 8. That would give you 14.625. So write the whole number 14, then multiply the decimal by the base you are working with to get the remainder. So this becomes 14 plus, how do we get the remainder? So this is 14.625. So minus 14, which is the number, you get the fraction part, which is 0.625. Then multiply by the base you are converting to, which is base 8, and you get 5 as a response. So you would see that if you do 14 times 8, 112 plus 5, it will give us 117. So this is to show you that this method is very accurate, fast, and correct and safe. So the next thing is to divide 14 by 8. So 14 divided by 8 will give us 1.75. 1 has the whole number. To get the fractional part, subtract the answer from 1, which is the whole number part. You get 0.75, and then multiply by the base you are working with, which is base 8, to give you 6. So if you do 8 times 1, remainder 6 that we got plus 6, you get 14, which is this. So this is to show you that this method is very correct, safe, and accurate. So now 1 divided by 8 will give us, it cannot go to be 0, and it will remain, of course, 1. The next thing for us is to record the remainder starting from the last remainder 1 here. So our 117 base 10 will be equals to, starting from the last one, 1, 6, 5, base 8. So let's proceed to the next question, which is to convert 269 base 10 to a number in base 4. So the first thing we want to do is to draw out our simple table. Very quickly. Write our base 10 number 269 on the right hand side, the number we want to convert to on the left hand side, and continuously divide. So this becomes 269 divided by 4. You would have 67 as whole number, plus, to get the remainder, take the decimal part to fractional part, which is 0.25 in this case. So just do your answer minus the whole number 67 to get the fractional part and multiply by the base 4, and you would get 1. So to confirm that this is correct, if you do 67 times 4, you get to 68, plus 1, which is the remainder, you get to 69. This is to confirm that this method is very, in fact, correct. So 67 divided by 4, we would have 16 as whole number. So the answer we get minus the whole number 16, we give us the fractional part multiplied by the base 4, we have 3. So to confirm that this is correct, 16 times 4, 64, plus 3, 67. So that is it. 16 divided by 4 will give us 4, remainder, nothing, 0. 4 divided by 4 will give us 1, remainder, nothing, 0. 1 divided by 4 won't go at all. We will record 0, remainder 1. And then we record all the remainder such that our answer 269 base 10 to base 4 will become 1, this 0, this 0, 3, 1, base 4. The next example, question 3, you convert 7385 base 10 to a number in base 16. Draw out our table. We write the base 10 number on the right hand side, 7385. The number we want to convert on the left hand side. So this becomes 7385 divided by 16, and that will give us 461 as whole number. To get the remainder, multiply the fraction or decimal part by the base you're working with. So this is minus 461. It will give us the decimal part, then times the base you're working with, which is 16, so we get 9. We divide by 16 again, so 461 divided by 16 would give us whole number 28. To get the remainder, multiply decimal part, which is 0.815 by the base 16, and that will give us 13. So further divide by 16, so do 28 divided by 16, and that will give us one whole number, 0.075 times 16, remainder 2. So 16 divided by 1, it won't go obviously, and the remainder will be 1. 2. We then can then record this as 7385 base 10 would be 1. 12 in base 16 is C. 13 in base 16 is D. And then 9 in base 16 is still 9. So we have our final answer. I hope you enjoyed my explanation as much as I enjoyed explaining to you. The take-home assignment. Remember, these take-home questions, I would be providing the solutions to this question in the next video. So do well to watch the video so that you can see the solutions to the questions. So convert the following to the base indicated. So the first question, convert 132 base 10 to a base 5 number. The second question, convert 6783 base 10 to a base 8 number. The third question, convert 45476 base 10 to a base 16 number. So see you in the next video, and remember, if you didn't understand it the first time, watch it again. That is the MathSense way. See you in the next video.